In this video, I am going to explain about Kirloskar twin-cylinder diesel engine. This is the test rig and those are the specifications. Here we can see the maximum bhp is 12, rated speed is 1500 rpm, bore diameter and stroke length are 87 and 110 mm. Before explaining the experiment, let me tell you about different parts of this engine. As the name implies, there are two cylinders. This is the first one, this is the second one. That's why it's called twin cylinder diesel engine. And an important part is here we place a fuel tank with a burette. This burette helps us to know the level of fuel inside the fuel tank. The fuel used here is diesel, and the fuel from the fuel tank first goes to the fuel filter, which is placed over here. After the filtration, the fuel is applied to two distinct fuel pumps. Each pump supply fuel to the cylinder through the injector, fuel injector. We know the function of fuel injector, which is to atomize the fuel, and we know for the combustion process it need oxygen, okay, for the combustion, and this oxygen or air can be measured using an air tank. A tank has a orifice meter and a manometer setup so that we can measure the mass flow rate of air, and then this air goes to the engine through the inlet manifold, and after combustion process it will rejected from the engine through exhaust manifold. We can distinguish these two manifold by simply looking the insulation. We only provide insulation on the exhaust manifold because the exhaust gas is very hot. Another important character is, yes, it is a manual cranking type diesel engine, means here is the crankshaft. We have to start the engine by cranking the crankshaft with a crank lever like this. We have to crank by just simply rotating the crankshaft, and before that we have to engage the decompression lever. Okay, now another important part is the fuel cutoff valve. We can stop the engine by pressing this fuel cutoff valve, and which will cut off the fuel so that the engine will stop. Aim of this experiment is to measure the brake power. So we provide a electrical loading system, which is simply a generator which convert mechanical energy to electric energy, and we can measure this electric energy which is correspond to the mechanical energy. So the energy produced by the generator can be measured using a voltmeter ammeter setup like this. The generator used there is a three-phase generator. That's why we use three different ammeters, okay, and a voltmeter. Before going to the experiment, we have to take some precaution. First, we have to ensure that the fuel is sufficient to start the engine. So we have to check the burette level and to ensure that fuel is sufficient to start the engine, and we have to confirm that the engine must start at a no load condition. No load condition can be achieved by offing these switches. Okay, we have to make sure that all these switches are at off position. Okay, and we start this engine by cranking, manual cranking, and we measure some parameters. For example, we measure the airflow, mass flow rate of air by simply looking the manometer level, and using the orifice equation we can find out the mass flow rate. And also we just close this valve, so that we can find out the time required to consume 10 cc of fuel, 10 cc of diesel, how much time it needed to consume 10 cc of diesel to the engine, so which is used for the specific fuel consumption. And also we can measure the voltmeter ammeter value. Since the switches are at off position, the value of ammeter will be 0 because circuit is open, so the value of current will be 0, and the voltage value will be there. And during the experiment we just close these switches. First column we just close these switches, and this bulb will glow, and we measure the these three ammeter values, current values, and also the fuel consumption rate, how much time it required for consuming 10 cc, and also the mass flow rate of air. We repeat the experiment by closing more switches like this in column wise and finding these parameters. From that we can easily measure the break power.